All right, welcome back. More patterns. We're talking about explicit formulas that we're trying to find out from patterns. And so here we go. And I did one of these before, where we have bacteria day 0, day 1, day 2, day 3. And I don't know if you can see them very well in the video, but take my word for it. They're there. And so again, the first thing I'm going to do is I'm going to write the numbers down. That'll help me. I see that there's 1 here. Here there's 2. Here there's 4. Here there's 8. Here there's 16, 32, and that's 64. Take my word for it. So I have these numbers, and now usually we'd say, okay, we're ready to go first term. But remember, I told you with patterns, we assume whatever's first is the first term, unless otherwise notified. And this one, it says day 0, which means that's not the first day. First day is over here. Day zero is considered to be something called initial amount. It means what you started with before you started going. Like, for instance, before I went out tonight, I had 20 bucks in my pocket. Before I did anything, I had 20 bucks, and then I went out, boom, and then I lost some money, and then a friend of mine who owed me some money. Whatever happens during that day can happen, but this is before you start. So, for instance, if you have a piggy bank full of money, and then you're babysitting on the side, you have money in your piggy bank, maybe 10 bucks, and then you babysit. Anything you add to that, that's after the initial amount. The initial amount is what you had there before you started. So this is actually day 0, and for an explicit formula, I need the first term. And this is not the first term. Day 0 is the 0 term, which means day 1 is the first term, day 2 is the second term, day 3 is the third term. So the first term is actually 2. And then I have to figure out, is it a rate or difference? Well, I can already tell. From here to here would be +1, but I can't go +1 there, so I know it's not addition. You should start being able to pick out exponential really quickly. But I can do times 2. Let's see if this works. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So I definitely think that we have a rate, and that rate is 2. It's getting bigger, so it's more than 1. And now I know it because of the rate that this is a geometric formula, which is a sub n equals a sub 1 times r to the n minus 1. And you can put that in parentheses if you want, especially if you're putting it in a calculator. And now I just substitute the values. A sub 1 is 2, the rate is 2, and this is to the n minus 1. Let's see. Yay! I got it. All right, now, Mr. Nelson, good. Show us how it's done.
Really
try
quickly.
it first. Pause it, by the way, people.
You can't do 2 times 2 here, just so you know. It's just 2 times 2. You can't say it's 4.
Oh, yeah.
Yeah. And then we'll move forward. All right, now you want to pause the video.
Sweet
Get
peas.
shot. And you should be done. All right. Same thing here. Normally we're not given this with sequences, right? And we'd say, well, the first term is 1, but we are given which term is which here in the sequence, and it says that this is the 0 term. Well, the 0 term is not the first term, and we need the first term for explicit formulas. This right here is a sub 0, which is called the initial amount.
Before you start.
Here's your first term, here's your second term, here's your third term. So let's go ahead and write the numbers of how many dots or whatever these are here.
I think they're sweet peas.
Sweet peas it is. So we have 1 sweet pea here. We have 3 here. We got 1, 2, 3, 4, 5 here. We got 1, 2, 3, 4, 5, 6, 7 right there.
Lovely.
So how do we get from 1 sweet pea to 3 sweet peas?
I add 2 sweet peas.
We're going to add 2 sweet peas because we're going to try addition first and not multiplication. Let's try again. Let's see, does add 2 work here?
I think so.
It does. 3 plus 2 is 5, and 5 plus 2 is 7. So we do have a common difference because we're adding, not multiplying. So our common difference is 2, and we just said our first term is not this one. It is this one is our first term. So our first term is 3. And because it's arithmetic, or I should say because it has a common difference, it's arithmetic, that's going to be a sub 1 plus our common difference times n minus 1. And then we just replace these 2 pieces of information. Our first term and our common difference. A sub n equals our first term, which is 3. Plus our common difference, which is a positive 2. And then times n minus 1.
Woo!
And there is our explicit formula.
Did we screw up? I think we got it right.
Did we do it?
Did we do it?
Oh, we did it right.
I was very nervous.
Look at that.
All right. Going on and on to the break of dawn. I think. Hey, come on, move. Hey, I like this one. Look at that. Go Utes. All right. So this says write the explicit formula from the given pattern. Right off the bat, I'm like, okay, well, I can see I have something's going on here, but down here, where am I starting? I'm starting at 2. 2 is not the first term. It's not the initial amount either. This is saying, this is how many Ute symbols I have after 2 whatever. It could be 2 minutes, 2 days, some unit of time, right? So after 2, I have this, and let's see how many we have here. We have 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18. And then after 3 terms, I have 1, 2, 3, 4, 5, 6. And after 4 terms, I have 2. It's definitely getting smaller. We could try to subtract. 18 minus 12 is 6, but 6 minus 12 is not 2. So it's definitely not a subtraction. So it must be a ratio of some type, which means that I'm going to be dividing by something, right? I know I have to multiply, but my brain, I think divide. I say 18 divided by what gives me 6? Like 18 divided by 3. 18 divided by 3 is 6. Let's see if that works though. Is 6 divided by 3 2? And the answer is yes. But remember, we know it's divide by 3, but we can't use divide by 3. Ratios have to be multiplication. So how can I write divide by 3 as multiplication? Well, what I can do is call it times 1/3. Whatever you're dividing by, just put a 1 on top of it, and you have that as a multiplication. Times 1/3. So I know my rate is 1/3. The problem is, I don't know what my first term is. Well, what I can do is, I know to go forward, I have to divide by 3. So what would happen if I had to go back? What's the opposite of divide by 3?
Multiply.
Multiply. So 2 times 3 is 6. 6 times 3 is 18. And 18 times 3 is
54.
54. So I can actually, even though they didn't give me that first term, I could go backwards to find it. Does that make sense? So now, they didn't give me the first term, but I was able to figure out what the first term is based on what I had and keeping that and just going in reverse in that pattern. So that means my first term equals 54. And now, because I know that I have a geometric equation because I have multiplication by 1/3. And because it's less than 1, you're going to see that it's getting smaller. If it's more than 1, you'll see it gets bigger. This is a sub n equals a sub 1 times r to the n minus 1. You can put it in parentheses if you want to. And that means I just replace the first term, which in this case is going to be 54. And I replace the r, which is going to be 1/3 to the n minus 1. And this formula will allow me to find any number in that sequence. Ooh. All right. Thank you very much.
Very nice.
Oh, we're done with that. Ba-da-bum, ba-da-bum.